Hello, good morning, everyone. Today is my interview for IIT Patna. That interview is for PhD admission. I'm willing to take PhD admission in Material Science and Engineering department, and that's why I'm going to be interviewed in half an hour. And before that, I'm trying to make a video on material science, the basics of material science, so that I'll be able to tell something related to material science in my interview during interview. So first of all, I would like to talk about stress strain diagram because it is the most fundamental topics in the material science because most of the properties of the materials are dependent on its stress and strain diagram. It's a very basic things, and we as an engineers must know about it. And though I'm going to take admission in my PhD program in material science engineering department, so it is a must for me to know each and every point and each and every basics of the stress and strain diagram. So the basic things in that is first of all we need to understand that how what is stress and what is strain. So stress is basically an internal resisting force per unit area. But before that we need to understand what is internal resisting force. Internal resisting force, how it is produced. So in fact, what happens whenever, suppose we have a metallic rod and we want to elongate it by using a tensile force. Just when we are trying to use tensile force on the mechanical member on the mechanical member, then what happens that it tries to elongate itself. It means that the distance between any two atoms of the material would like to go away from each other, but the internal bonding of the material try to try to maintain its own position. So in this way an internal resisting force is developed inside the material. External force is trying to stretch its atoms, but the internal atomic bonding tries to pull it up to its original positions. So an internal resisting force is developed against the externally applied load. So that internal resisting force is actually the stress that develops stress inside the material. So in most of the time we see that the externally applied load is equal to the internal resisting force. So sometimes we can say that a stress is simply external applied load divided by area, cross sectional area. But in fact it is not the applied load. In fact it is the internal resisting force that is developed inside the material when we apply some type of external loads. So basically, we understood that basically stress is the internal resisting force per unit cross-sectional area. And what is strain? Strain whenever we apply load, it tries to elongate it, and sometimes when the applied load goes beyond the strength of the material, then it elongates. If some deformation occur in the material, and this deformation per unit length or any type of dimension per unit dimension is known as a strain. So first of all, sometimes a question is being asked in the interview that in stress and strain, which is the dependent quantity and which is the independent quantity, and why strain is shown on the x coordinate only. So first of all, for understanding it, we need to understand that how is strain produced. So whenever we apply load, after applying the load, some deformation or elongation is seen in the material, and that elongation is actually the strain produced in the material. So we can say that uh, the most independent quantity, the first independent quantity is the applied load, because the applied load, it is completely independent. It is not dependent on any other quantity. We apply load, and application of load makes a deformation in the body, means that application of load produces strain in the body. And because of the strain, because of the strain, the deformation has already occurred in the material, it will try to regain its original shape. And for in order to gain its original length, it will try to develop an internal resisting force, and that will cause the initiation of stress. So in fact we can say that applied load causes strain in the material, and that strain causes stress in the material. So ultimately